Alright, this is a quick video on the first section of Unit 4. And it was using the idea of inverse variation, joint variation, direct variation. And what you have to remember is that these are just words to tell us a relationship between two variables or more than two variables in the case of joint. So let's first, here's what if you have a direct variation or relationship, the general form of the equation is y equals k over x, where k is just some constant, and x and y are the two variables that have this relationship.
Mrs. Eubank to the office, please. Mrs. Eubank to the office.
And I inadvertently wrote down the inverse variation there. So here's what a direct variation looks like, y equals kx. And it doesn't just have to be a y and an x in there. For example, y equals kx squared. That would mean y varies directly with x squared. You have to excuse the track team out in the hallway. So those are what direct variations look like. We could have inverse variation. In that relationship, I'd written it earlier, y equals k over x. Okay, notice the y is in the numerator on the left side and the x is in the denominator on the right side. And the reason we call these direct and inverse is direct, if x gets bigger in a direct relationship, then a y will get bigger because you're multiplying whatever k is times a bigger number. So y automatically follows suit. They have a direct relationship with each other. The inverse variation or relationship does the opposite. As this x gets bigger, because it's in the denominator, you're dividing a bigger number into whatever k is, and so y would get smaller as x got bigger. So they do the opposite of each other. Again, it just doesn't have to be k and an x. It would be y equals k over the square root of x. In this case, you would say, hey, y is inversely proportional or is inverse with the square root of x. And that tells us that that x is in the denominator. And then thirdly, we have the joint variation. And they look like this, y equals k, and then it varies according to two variables. Okay? And again, there it's varying jointly with x and z. Here it's varying jointly with x squared and square root of z. Okay? It just means both those variables and whatever's done to those variables are in the numerator. So those are three variations. And now we can use these. They tell us a relationship, and then we can use the general form to write the equation. And so here would be an example problem. You're told immediately the relationship y varies inversely with x. Okay, so there's a bit of information a problem might tell us. And they say if or when y equals 12, x equals 4. So right away, they've told me everything I need, or I know everything about this problem that I need to write the equation. Y varies inversely with x tells me y equals k over x. It has this model. The ordered pair they gave me, and that's what this information is. It's an ordered pair. It says x is 4, y is 12. I can use that to actually figure out what the constant is in my model. If y is 12, x is 4. And so I can multiply both sides times 4, and I find out k is 48. Okay? So for this problem in this relationship, the equation is y equals 48 over x. And then we can answer questions like, hey, if x is 3, what's y? Well, it's pretty easy to see how to solve that now. We plug the 3 in, and we find out y is 16. Let's do, and so that's the general idea. Let's do one more. We'll say y varies jointly with x and z, and if x equals 2, z equals 5, then y equals, I don't know, 30. Okay? And again, with that information, I can figure out exactly the full equation. Y equals k x z. I get that equation from the fact that it said jointly, and this is my joint model. Then I can use the fact that when y is 30, x is 2, and z is 5. That's 10, and divide both sides by 10. I find out k is 3. So now I have my equation. Y equals 3xz. Give me another xz, and I can figure out a corresponding y value that goes with that group. And finally, the last one is off of the classwork on the our website. It says circumference varies directly with the area of a circle and inversely with the radius. Then it gives me a few numbers to help me find some stuff. But let's first look at this statement. Circumference, so we use C, varies directly, so we got a K in here because we have to have some constant, with the area of a circle, so we'll put area, and inversely with radius, so we'll put R in the denominator. So there's our general model for this equation. Now here's the rest of the information they give us. They tell us C equals 18 when A is 27 and R equals 3. So now we can use this to actually find out what this constant is. So we go 18 equals K times 27, because A is 27, over radius 3. And we solve this for K. So 18 equals 27 divided by 3 is 9. K is equal to 2. So the general formula, or the equation for this relationship, is C equals 2 times the area over radius. And that's all there is to the first section.
Quit walking! Rack City. Rack City. Rack City.
Hello.